Good morning, everybody. We'll be starting the presentation, and just wanted to let everyone know that we appreciate you being on the webinar this morning. And a lot of different things I want to mention to begin with. Fox Valley Metrology had, just to tell you a little more about Fox Valley Metrology, back up. Our organization started in 1996, and we have currently 5 locations. We have, obviously, our headquarters here is in Oshkosh, Wisconsin. We have one in Stacy, Minnesota, which is close to Minneapolis, St. Paul. We have one in Rockford, Illinois, Fenton, Missouri, which is basically close to St. Louis. And now we also have a location in North Carolina, which is in Monroe, close to Charlotte. So we have a full service lab here. We can do repairs, calibration obviously is our main focus. We also sell hand tools, precision tools, equipment, capital equipment, CMMs, optical comparators, just about anything that you can think of, vision systems. So we also have a dimensional lab where you can send first article pieces or parts, and we have 2 CMMs here. We have 3 vision systems, so we can check your parts. All we need to get that going for you, to quote, is for you to send a print. So that's a little bit about Fox Valley Metrology, and we'll begin here. Thanks for bearing with me. All right, so you should see on your screen here, again, we want to thank everybody for being here. This webinar is recorded and will be sent to everyone. Also want to let you know that normally this is a paid seminar. I can come on site and do the seminar to your group. Typically it takes about 2 hours. So if you are interested, let us know. We can send you a quote. Bear with me. All right, so I just wanted to mention to you the following information has been okay. I'm not sure if you can see the screen right now. Okay, the following information has been derived from Starrett Tools and Rules booklet, editorial fundamentals. And again, my name is Tom Dorn. I've been with Fox Valley for 15 years and also have about 40 years of experience in manufacturing and sales. So hopefully you'll get something out of the presentation, whether you've been new to the industry or you've been in the industry for quite a while. All right, so again, this is Precision Hand Tool Seminar. What we're going to be covering today is topic 1, what is precision accuracy, getting to know your precision instruments, how to select the correct instrument for the job. Topic 4 is how to properly clean your precision instrument, how to properly store your precision instrument, and lastly, the hands-on. So what is precision? What is accuracy? Accuracy and precision defined. Accuracy precision are 2 important factors to consider when taking measurements. Both reflect how close a measurement is to an actual value, but accuracy reflects how close a measurement is to a known or accepted value, while precision reflects how reproducible measurements are, even if they are far from the accepted value. Example here, I have, for those that do target practice, bow and arrow, this is a good illustration. So accuracy and precision, as you can see on the bottom left-hand corner, accurate but not precise. So you are hitting the target, but it's not very precise. And precise but not accurate would be the middle one. You can see all the X's here are all in one location. And lastly, what we want to shoot for is the bullseye. And you can see accurate and precise is in the end one. What effects are there when accuracies aren't met in proper measurements? Parts may be scrapped. Parts may have shorter lifespan, wasted time and money, lost customer, safety is at risk. Hopefully you won't experience any of these things, or you haven't experienced these things, but just keep in mind there's some things that you can do to, obviously some things are going to happen, but if we can reduce the effect of that happening, that would be a good thing. Again, this is a little screen here, or slide, how to obtain precision and accuracy. For those that, this time of year here in Wisconsin, hunting is pretty important for everyone here. Well, I shouldn't say for everyone, but a lot of people. So you can see how to obtain precision and accuracy. Obviously, our goal is to hit the bullseye every time. So how we can, how he or she, in order to increase the odds of a successful hunt, obviously, they got to do several different things. And obviously, sight the gun, be prepared, look ahead of time, scout out the area. So there's a lot of things to consider when you are getting ready to get ready for the hunt. So again, preparation is no difference if you want to have an accurate and precise measurement. So first, let's look at, even though we may not have measurements that are this accurate, it's still worth a look to see what measurement terms, how important this is. So a micron is 40 millionths, just round up to 40 millionths, or 0.001 millimeters. I put a slide in here just to show you give you a picture or closer view of what that micron looks like. The very dot in the middle is a micron. And again, that's 40 millionths. The larger one is actual a human hair, which is 3 thousandths, 3.5 thousandths, or in my case, it might be a little less than that because I don't have a lot of hair, as you can see. So, but the other thing is, one of the other ones that you see is a particle of cigarette smoke. There's a particle there. But the other one is dust particle. This is real important to keep in mind because, again, you can see it's a little more than a thousandth of an inch. So, 1.5. So that's real important, for us to consider when we do measurements. So again, micron is 40 millionths. Hair is about 3.5 thousandths. A dust, you can see, is about 10 microns in diameter, which, if not removed, will affect your measurement. So understanding decimals. So a lot of you use tape measures. That is the most common instrument out there. And then next to that is steel rule. But again, it all depends upon how accurate you need to be. That might be for when you're just starting to produce a part. You might take a quick measurement with a steel rule just to see, how close you are before you make your final cuts, or to be more precise. So understanding decimals, as you can see on the steel rule, We have a 64th and a 32nd on that steel rule. If you think of it, there's 64 lines up to 1 inch, and the bottom one is 32 lines. So keep in mind what we just talked about, the micron. Just think of 10, it's mind-boggling to think of what that is. Again, 40 millions, you got, again, you don't have anything that close, but think of thousands. There'd be 1,000 lines in there. 10,000s, again, 10th of a thousandth would be, again, 10,000 lines. So when dealing with gauge accuracies and tolerances of thousands or 5/10ths of an inch or more, what can ruin the accuracy of your measurement? Obviously, dust, dirt, and grime, which is why I showed that screen before about the micron. You see, you got a good picture of how that could affect your measurement. Temperature, thermal expansion. Again, what that basically is, the temperature in your room should actually be the same as your instrument. So if they don't match up as far as temperature, you're not going to get as accurate of a reading that you could. You want to take off the burrs on your parts. You need to have, again, inaccurate measuring instruments will affect that. Improper use of precision tools, improper storage of precision tools, selecting the wrong tool for the job, and also, obviously, there's other factors. As you can see, many things to consider when trying to make a measurement. So how to obtain that precision and accuracy? For a machine operator or a quality professional, what can he or she do to increase the odds of achieving an accurate measurement? A couple of things to consider that I listed here. Make certain that your precision tools are in working order. You don't know the last person was using it, maybe they dropped it, so you want to make sure that it's properly running before you use it. Have regular checks with masters, and I'd recommend doing that before you take a measurement. Have your precision tools calibrated. Requirement for companies that are ISO registered, otherwise it's customer driven. Check parts to make sure there isn't any burrs, and if so, remove them. If there's any variation in temperature from where the gauge is stored and used, acclimate the gauge before use. Again, there could be a difference if you have a tool out on the shop floor and your parts are really hot. Again, you want to make sure that they are the same temperature before you take a measurement. So, especially if it's on a machine and it's hot, again, you might want to wait a while or put coolant on to bring the temperature down. Again, if the temperature is different, again, we'll talk about a few other things you can do to reduce that difference. Have your precision tools protected when not in use. I've been to a lot of different shops, and it's important while you're making chips on a machine, to have protection on the precision tool. Put it away from the chips that are flying, or cover them while on a table. That's something to keep in mind. And then also place on a clean surface and clean instruments before and after use. Instruments to increase accuracy, obviously a stand or a length standard are things that can help you. And then also there's on the length standard, there's a insulation there to protect from your heat from your hand as you're holding it. So I have a illustration here of a stand. So this is a mic stand. Hopefully you can see it all right. Just an illustration of how you can do it. Again, the nice thing about that is you have smaller parts. Especially like this one, it may be a little difficult to take a measurement on a 2 to 3 inch. That's what this one is. So you place it on there. If you have a larger one, I think this is probably up to like 4 inches or so. So keep that in mind. A stand like this might be very helpful for you. Other ways is to maintain accuracy is using a Calipers on the very top to do periodic checks with that caliper to make sure that it is accurate. The other one is a Micrometer on the bottom. Some call it a mic tree. So again, measure regular checks and to make sure that everything is running properly. Also, gauge blocks could be very helpful as well. I have an inspection micrometer set listed there. That includes a optical flat, which we'll get into later, as well as a rectangular gauge block set. There's also square gauge blocks as well. Another way is master pin or ring gauges. So we go to the next topic, which is getting to know your measuring tools. Different types of calipers. So as you can see on the very top is a vernier. Not a lot of companies have verniers anymore, but if they do, they're usually the larger ones, like 24, 40, 60 inch I see out there. And that's what I used to use when I was a machinist as well on some bigger parts. But keep in mind, those two are typically needs to have a couple of people to take that measurement. Not always on those, but it's again, we can get into that a little later with the micrometers being larger. But the dial caliper on the bottom, and then also the digital caliper. Parts of a digital caliper, obviously there's the main parts. I have quite a few listed here, but the main ones are the upper jaw, the lower jaw for the upper one is for inside measurement, the lower jaw is for outside measurements. We have the scale, we have depth rod, and end of display. How to read a dial caliper, I skipped as far as a vernier. Not a lot of people are using verniers, but if you do need help on the how to read a vernier, we can send you a tools and rules booklet, and which has that information in there. As far as reading a dial caliper, I do have one here that I want to show you. So basically, again, here's the 6-inch dial caliper, and every rotation is 100 thousandths. But as you look at it, every line is 1/1000th of an inch. Again, we talked about that before. Keep in mind, again, 1,000. If you're looking at the STU rule again, that's 1,000 lines. So this is a lot more precise than what you would get with a STU rule, and the accuracy is about a plus or minus 1/1000th of an inch. And again, each revolution is 100 thousandths, and if you take 10 revolutions, you got 1 inch. Not a lot of people realize that there's actually 4 ways to measure with a caliper. Typically, you have your inside, which I'll try to show you here with a test piece. So basically, you have your outside measurement, which again, you take a measurement like this, and always, I'm not sure if you can see here, but you always want to make sure that you don't use the end of the jaw, but on the end, on the middle part of it. So you just rock it back and forth. We'll get into that a little later, but here's outside measurement. It's inside measurement. Hopefully you can see that inside measurement. And then also we have a depth. There's a depth rod here, so you can take a measurement that way. And the lastly is a step measurement. So basically, hopefully you can see this. Hopefully you can see this is there's a actual. This is a machine surface on the bottom here. Sorry about the lights going out there for a second. I guess we got to move more. But anyway, we have machine surface on the end here. And then we also, the draw here is out a little bit. So you just place it on the bottom, slide it down, and you'll be able to check steps. Oh, so digital and standard types. So we got digital, and we have just a standard mic. Main parts of a micrometer. So we have, just like we did with the caliper, we had the slide, which is real important for sliding the caliper that draws back and forth here. Main parts of a micrometer is, one is the frame, two is the anvil, solid anvil, three is the spindle, four is the lock nut, five we would have the sleeve, six is the thimble, and seven the ratchet. So again, that gives you exactly what I just had mentioned. The ratchet knob on the end, is something that you won't see on all the on the mics. Some have a thimble, and this one has a ratchet. So how to read an outside mic? Obviously, this is a more accurate instrument than the caliper. Again, the caliper is plus or minus 1/1000. With the micrometer, it's more like a plus or minus 1/10. So you do have a micrometer here, as we have on the stand right now. The micrometer has, again, I'm not sure if you can see this, but again, every line on here, the one revolution is 25 thousandths. You do 4 revolutions and you got 1 inch or 100 thousandths, all the way up to 1 inch. So this range is actually a 2 to 3 inch, this micrometer. The other thing is there's some lines on the side here. So with that, you can get 10 thousandths of an inch. So, so keep that in mind, depending on what accuracy you need for your measurement. Obviously, there's different types of micrometer sizes. Most common is a 0 to 1 inch, but obviously the one on your left is a very large one, and actually, some of the larger parts that customers are making, you would need a larger one, and that is a 2-man operation. One person holding the anvil, the solid anvil, while the other one is operating with the spindle. So how to select the correct instrument for your measurement is topic 3. This is hopefully, if you don't get anything out of this presentation, this is one thing to, I guess this is the one main thing I want to hone in to everyone is the 10 times rule. Consider the graduation and accuracy. As we just talked about with the micrometer, you can have a thousandths, or you can get a 10 thousandths. So if the resolution is not 10 times better than the tolerance, then you're not able to resolve the measurement to a point that it has value. You'll then need to select a precision instrument that is within the tolerance needed. So in other words, if your print says 1/1000 plus or minus 1/1000 of an inch, you've got to make sure that you use a instrument that has, like we just talked about, that micrometer that has a 10 thousandths graduation. You got to make sure that you use the correct instrument. So hopefully that makes sense. If yours is a little closer, like a 5/10 of 1,000, you want to make sure that you use a micrometer that has a 50 millionths, resolution. Calipers and micrometer graduation. So again, as we talked about, calipers typically have the accuracy of plus or minus 1 thou, depending on the size, and typically micrometers typically have 1.5 10 thousandths depending on the size. Accurate and repeatable measurements. Obviously, like we just mentioned, there is several different micrometers to choose from, and this actually has digital, is a digital, and on the left I have a rapid micrometer, which actually is very accurate. And the nice thing about it is it has a floating spindle. So it doesn't matter who operates it. I know, because feel is very important, and we'll get into that shortly. But again, this is a very accurate and repeatable micrometer. So hopefully you can see that. And then also the micrometer that is listed on the right is a submicron micrometer from Mid-Toil. So we also have specialty micrometers. This is a small sample size of what's available. But the one on the left is a blade mic, which can be used for checking grooves. The one on the right is a unimic, or actually a tube mic that can be used for checking tube thickness. Also, specialty calipers. The one on the left here is on the top left-hand corner is a offset caliper. And we also have a inside groove caliper, a knife, inside knife caliper, and then also a tube caliper. A lot of different ones available, but just to give you, again, a small sample size. Carbon fiber calipers are also an option when you got some larger measurements, and they also have interchangeable jaws, depending on what application you have. Also want to touch on IP ratings. Again, this is something that's in the tools and rules booklet, or you can go online and pull that up. But the first digit is a level of protection that the enclosure provides. The second digit, level of protection of the equipment inside the enclosure against water. So if we, for instance, we go back to, well, pick this disc mic here. Again, this is a specialty mic for checking gears and splines. So it does have a IP65 rating on here. If it is rated, it'll say it on the gauge. So again, just wanted to point that out. The next slide here shows you exactly the IP ratings explained. Most popular and most common you'll see is on the first digit, 5, which is protected against dust, limited ingress, no harmful deposits, and also 6 being totally protected against dust. Second digit is, again, the most common you'll see is 4, 5, 6, or even 7, which isn't listed here. But the 4 is protected against water, splash from all directions. So basically, if you're taking measurements on a lathe or something, dropping coolant on, that would be okay, as long as it's just a few drops. 5 would be protected against low pressure of jets of water. 6 would be strong jets of water, and the last one would be 7, which is fully submersion. You can actually hold your or have your tool in a water or coolant, for 45 minutes, and it won't harm it. As long as you clean it before you use it, you should be good to go. Does anybody have any questions? About more than halfway through the presentation, and I got about 15 minutes left. I'm hoping, and we'll leave that also for more questions. So again, I forgot to mention to you at the very beginning that on the left side of the screen, there's question and answer. So you just click that and ask your questions, and be more than happy to answer those for you. So I'll just wait a minute or two, give you an opportunity to send your question. All right. So no questions at this point. Hopefully it is beneficial so far, but again, we have 3 more topics here and we'll get started. So topic 4 is how to properly clean your precision instruments. I clicked the wrong one. Here we go. All right, that would help to have the right direction here. So again, most common damage to micrometers and calipers, obviously, as we talked about, is dirt, grime, and coolant. So again, these precision instruments are is very important to, before you use them, to check to make sure the instrument is running smoothly and properly. If you know that something isn't correct of the tool, or the tool is damaged, it's your personal responsibility to inform a supervisor or the quality department immediately. Make them aware of it. Even if you didn't do it, if you dropped it or whatever, just make sure that you say something to the quality manager or technician so that they can correct the problem before you start using it. Properly cleaning of instrument. Again, this is very important to make sure that you clean them before you use them. And again, what I have is, and what I recommend is to use a lint-free cloth, which I do have here. We don't have any lint left on the precision tool. So basically what you want to do is take M1 or some type of a lubricant, and you want to spray it here. Spray a little on there. And just on a caliper, basically what you want to do is you want to clean the top, well, clean the jaws off, wipe the edges off, and make sure you don't have any lints on it. And then also very important is to, on the top and bottom of the scale here. So that's how you clean it. Very light oil on there. You don't want to put too much on, otherwise you could damage your the inside of your caliper. So again, as you can see, just a real light wipe of the cloth to the caliper, and same thing with the micrometer here. What you want to do is just wipe off the both anvils, the spindle and the anvil, and maybe put a little on the spindle here. When it slides, it'll smooth. It runs smoother. Using micrometers and calipers, accuracy of a caliper and micrometer have, the flatness of 2 measuring surfaces. That's where a lot of wear will occur. We want them to be parallel to the 2 measuring surfaces. And obviously when these surfaces wear, the accuracy diminishes. So again, that's real important to have regular checks and also calibration. I can't really tell you how often to have your tools calibrated. It's totally up to you and depends on how often you use your gauges. Most customers have an annual calibration cycle that they have, so just keep that in mind. If the surfaces have any grime, or a small amount of wear will occur as soon as the surfaces meet the part to be measured. Obviously, again, it's very important to wipe that off. Again, if I take a measurement and not clean the part and the tool, that when I take a measurement, that will affect the measurement, and also it'll affect the wear, especially if it's metal. You want to make sure it's clean. So how to check for flatness and optical flats. Obviously here at the lab, there is, a little more that we do, but here's an optical flat. I'm showing you a picture of it here. So basically, you take your micrometer or your caliper, as you'll see in the next screen. you know, or in this case, a gauge block. You put it on the surface here, and you want to see straight lines. So if it is straight lines on there, as you can see on the left, that gauge block, you know, is very accurate. On the right, you know, you can see on the very bottom there's it's straight, and on the very top there's it's curved a little bit. So that means that you know, that should not be forgotten. You need to address that right away. Send it in to be relapped, or you know, or take it out of service. So it's just some important things to keep in mind. So properly store your precision instruments. And the next one will be, if you recall, we'll be doing a quick measurement. So this again is important. Properly store your calipers with a jaws closed with a slight gap. So when you're storing it, you want to close it all the way to just a little bit gap there. And then if you have a lock nut, you want to make sure you lock that. So that way it'll protect it. If you have it in a cabinet or something, it won't slide around, and it'll be protected. If, again, that's the reason. So it's bumped, the anvil and spindle won't jam together. Storing digital micrometers, again, same thing. We want to have the caliper slightly open, that gap here, and if you have a lock, lock it. If not, you just have well, another thing is I see a lot of people putting maybe a piece of paper in there so that it can't be damaged when not in use. Also, changing battery, usually, you know, depending on how often you use it, but the gauge loses its absolute zero reset, so you just press that, and you should be good to go after you change the battery. And again, as we talked about, if there's a locking mechanism, use that when you store it. Again, a little illustration of a storage cabinet. Again, if you have drawers, you want to make sure that they're not sliding around, so have dividers in there, or a cloth or something on the bottom. So again, if the measurement tools are used in a harsh environment with coolant, mist, metal chips, and debris, you want to wipe it down before you store it. Also, very important to maybe have some inserts in the cabinet so that you can protect it when the drawer is closed. They're not sliding around. So I see that being a real way to protect your instruments. So lastly, how to effectively use your precision instruments. Again, this webinar is only on calipers and mics. Also do some with indicators and different things. So keep that in mind. So a slight touch. Want to get a micrometer here. And this is important as well, where, again, I have a micrometer in my hand. Technique is when you take a measurement, and I have this practice piece here. So you want to take a measurement, you open this up enough. And again, I'll back up a second here. Real important is before you use the micrometer is to slide it on a piece of paper here. And what I do is just slide it across. Not a good practice. And again, you have oil in your hands, so I see a lot of people using their thumb or their finger, you know, wiping it off. Well, you're going to be putting a little oil on there, so it's better to slide it across a piece of paper. So just keep that in mind. So again, using a micrometer, you just open it up, and hopefully you can see it okay. Rock it back and forth to make sure you're in the middle. And then you should always be able to, when you take it off the micrometer, off the piece, hopefully you can see that. You want to make sure that you're able to move it. Rock it back and forth and move it. If you tighten it too hard, obviously that's not a good measurement. You got to be able to move it, rock it back and forth. So you take it off and you got your measurement. Where a caliper, again, a little different with a caliper, where a couple of different things you want to do. Again, slide it, the draws, slide it across like that, and wipe off the inside draw if you're using that. But again, I want to point out what I like to do is before I take a measurement, obviously you want to see zero. So what I do is I slide it across, and I want to put this up in the light here again to see if there's a gap. If you can see a gap, you may have a burr on your caliper, on your jaw, and you can hone it or real light hone just to take that burr off. So again, that gives you a little idea. Again, for the measurement, what we want to do is, as we talked about before, we want to go toward them. Hopefully you can see that. You don't want to use the end here. You want to use it here toward the middle. And again, you rock it back and forth. And you should have your measurement. Also, zero it out when you start. As you can see, we're on 0, and you should be good to go there. Experienced machinists can measure accurately to 2/10,000ths of an inch. Again, feel is very important. As you can see on the bottom there, I have a friction thimble, and again, feel is very important on that one. The ratchet stop, as you saw on the 2 to 3 inch that I had. This micrometer here does have a ratchet on it. So 2 to 3 clicks is all you need. What I try to tell people is ready, set, go. So you want to have more than 2 or 3 clicks. But if I do, it's going to be tight on my measuring surface, and you won't have a accurate measurement. So clean measuring tips and face before use. Remove cutting chips, dust, burrs, and other foreign substances from the surfaces to be measured. Gauges should be checked to make sure it's running properly. And again, as I talked about, you should make sure it reads 0. If it doesn't, press on 0, and you should be good to go. Take care that the gauge is perpendicular to the part to prevent measurement error. To assure this, keep the flat measuring face in full contact to the workpiece. Number 4 is to measure a part in position where the display cannot be viewed. Press on 0 or the hold button and remove gauge. That means basically is if you're taking a measurement and you're not able to see the other side, if you're left-handed, obviously you're checking like this, opposite here on the left. Actually, you're checking like this. You're not able to see the display. There should be a hold button on there, and it'll actually remember your measurement. Not a lot of people realize that, but that is a real nice advantage on the digital calipers. Moves them, again, as we talked about, move the measuring tip and face to be in contact when they're reading. Actual part thickness will be listed on the digital readout. Always apply constant force on the thumb wheel during operation and measurement. And then also tighten locking screw to hold the reading. This is something we didn't talk a lot about, but working temperature is 32 to 72 degrees. Do not put gauge near strong magnetic fields. Keep dry. Liquid getting into the caliper will damage electronics. Do not apply voltage on gauge like engraving with an electric pen, which used to be done quite a bit years ago. And also measuring tip and face should be carefully protected from being scratched or damaged. Do not abuse or do not operate abruptly, drop or strike a gauge. A lot of times people will drop their calipers on a table. They should be really careful. This is a measuring instrument and it's very precise. And if you want accurate readings, you won't have them if you don't treat them properly. So again, the proper use of outside micrometer, we kind of touched on that a little bit. Clean the micrometer gently. Make sure everything is clean. Remove any burrs on the parts. This is something that is important as well. Never rotate the thimble to let the spindle contact the workpiece. So basically what it's saying is, I don't want to have this riding against the, when I'm taking a measurement, you don't want it sliding across and damaging the side of it. Right? Grip the heat isolation plate, which is important as well. So I do have an example here. Here's a heat isolation plate, as you can see on the bottom here. What that is actually when you're taking a measurement, if you hold the micrometer long enough, you actually change the temperature of the gauge. So this heat isolation plate is very important if you're going to be taking measurements for a long time. This is more for production. If you're holding on to the micrometer for a long period of time. Measuring faces should be carefully prevented from being scratched, hit, or rusty. So again, be careful with the gauge. Spindle should be oiled to avoid getting rusty. If you're going to be storing it for a while, you want to make sure you put a little lubricant on there. Protect it. Everyday care of precision tools, again, wiping down with Kim whites or impregnated tissue, lint cloth, lint-free cloth, and a little alcohol, denatured alcohol, and remove whatever material may be on the tool. So again, wipe that off gently and then store it as we talked about. That will prevent corrosion or anything if you're not using a tool for a long time. That actually is the end of our presentation. If anybody has any questions, I'd be more than happy to help. Hoping that presentation was well received and you're able to get something out of it. But we'll just wait a few minutes for any questions that someone has. Nothing at this point. Again, all you need to do is click on the side here. Any questions here? Okay. All right. It doesn't look like we have any questions at this point. Thank you for your time and hope that it was very beneficial to you.